Hello, hello, hello. Welcome all to the stream. And I have started today early, as told you, because some people complained that I am coming live little late. So today we are starting early. And yesterday we learned the Kubernetes basics, and we have set up a local setup like this. So we are using the Kubernetes locally so that we don't have to pay any money for as of now, but in future we will. So let me show you how the dashboard is looking for this right now. Kubernetes, yeah. So this is the dashboard. How is it looking right now? Let me close some tabs. System design. Hey, not my playlist. Ingress. Yeah, I was reading about Ingress because this is something that we are gonna need it now. Okay, so is it all set? Let me see. Yeah, let me check the stream. स्ट्रीम क्यों नहीं दिख रहा मेरे को? Am I live? Can trigger the notification, but yeah. Am I audible? Let me check. Hello, hello. Yeah, perfect. So we have this pod. So my friend told me, I took this advice just now, and my friend suggested me that pod is nothing but a EC2 instance, but it already has all the things like the OS and all which is required. So what it says, we ran this command kubectl create deployment. So we have created a deployment image, this gcrio slash google samples kubernetes bootcamp. Great, you have just deployed your first application by using by creating a deployment. So we have created a deployment. Yeah, this is something that we created. Okay, so what next? Mm, Search for a suitable node where an instance of the application could be run. We have only one available node. Schedule the application on the node. So let me use chat GPT in right with this, because chat GPT is gonna help me a lot. डॉक्यूमेंटेशन यहाँ तक सही था, इसके आगे we need chat GPT. I trained one instance. Yes. uh, I run this command and I can see it working now. Okay, so is this Kubernetes deployment. When you ran, Kubernetes did much more than simply run container. It created this chain of object deployment, replica set, pod, and container. uh, what each component does: deployment, the highest level object, stores the desired state. Example, I always want one instance of this app running. Okay, how many instances it will run, it is said in this. Revision history limit, total available. Yeah, pods 1/1. It decides this how many pods there will be at any given point in time. Then what it says, mm, ensures requests number of pods are running. If pod dies, it creates another one automatically. Okay, deployment's job is this: the smallest deployable unit in Kubernetes. Pod is the smallest deployable unit. This is also something that we ran uh, on this command. So our goal is to now use our images that we have created. Just a second. This goal is this. Okay. Uh, to get list of deployments, use kubectl get deployments. I can see the deployments right there. Uh, we see there is one deployment running a single instance of your app. Okay, the instance is running inside a container on your node. View the pods are the running inside pods that are running inside the Kubernetes are running on private isolated network by default. They are visible from other pods and services within the same Kubernetes cluster. Okay, but not outside of the network. When we use kubectl, we are interacting through an API endpoint to communicate with our application. We will cover other options on how to expose your application outside the Kubernetes cluster. This is what we want in module 4. Also, basic tutorial. We are not explaining what pods are in any detail here. It will be covered in later topics. Okay, we will wait. Uh, okay, the kubectl proxy command can create proxy that will be forward communications into the cluster wide private network. The proxy can be terminated by pressing Ctrl C, okay, and won't show you any output while it's running. You need to open a second terminal window to run the proxy. Uh, do we need this proxy? We now have a connection between our host. Okay, let's create this. Mm, Let me go here and create this. Starting on serve this 8001. What it's serving? Paths. These are all the APIs that container has, or the pod has maybe. If I go here, kind API version this. Okay, API v1. What it what it what are these things? I've seen these things in past as well. Auto scaling. V1 horizontal pod auto scalers horizontal pod auto scaler works. Okay, let's see. We now have a connection between our host terminal and a Kubernetes cluster. The proxy enables direct access to the APIs from this terminal. These APIs what it's talking about. Okay, what about these? But you can see all the APIs hosted to the proxy endpoint. For example, we can query the version directly through the API using curl 8081. Yeah, this is what we will get. Sorry, curl in the browser. It should be this major minor emulator Linux ARM 64 platform. Okay, fine. Then note if port 8001 is accessible, ensure the kubectl proxy that you started above is running in the second terminal. Yeah, it's not accessible. Yeah, it's accessible, so no, we can ignore this. The API server will automatically create an endpoint for each pod. Okay, based on the pod name that is also accessible through the proxy. First, we need to get the pod name and we will store it in the environment variable pod name. Mm, okay, let's run this command. This is occupied. This is also occupied. This is also occupied. We need one more terminal. So you new tab. Uh, Ocean novel man page. Let's use red sands. Yeah, okay. Let's run this command. Okay, and then it says echo this. Name of the pod is this is the pod that we have running. Let me fix the placement of the windows. This is how it should be. Okay. You can access the pod through the following proxy. So we have to edit this command. Let me edit this. And our pod name is this. Copy. Now UTC. Okay. In order for new deployment to accessible without using proxy, a service required which will be explained in module 4. View pods and nodes. So this is next we have to learn. So let's go on this page now. Okay. So if you guys have any doubt like how what we did till now, I can explain you. You just mention in the chat that what I am doing, and I'll explain you all the things that I am doing right now. So viewing pods and nodes, this is what we actually want to know, like where these are residing. Learn about Kubernetes pods, learn about Kubernetes nodes. Okay, these are all things. The shell commands in the tutorial use POSIX shell syntax, which is supported by the default shells on most Linux and Mac OS system. For example, Bash, JSS, SH. Windows user, fuck that. We are Mac users. Kubernetes pods. A pod is a group of one or more application containers, such as Docker, and includes shared storage volumes. So it's exactly like the container. Container also has the volume, and one container can have multiple images. So each pod equal to container. No, pod is not equal to container. Pod is a wrapper or a group that holds one or more container. But then this line is almost same. A pod is a group of one or more application. Uh, Let me ask this to ChatGPT because this is route. Last in the last to last session we did Dockerization and then deployed it to container. So uh भाई क्या ले लिया भाई बहुत मस्त चश्मा है भाई तेरे को नहीं समझ में आया फिर मस्त चश्मा है भाई ये ऐसे मत बोल आ, भाई ये जो मैसेज आ रहे हैं ना ये चार्ट ब्रेन एप्लीकेशन मैंने बनाया हुआ है इट ट्राइज टू मेक सम बैड जोक्स so pod is equal to containers uh, cause in docker compose also had the volumes and pod also has volumes. Pod is not equal to container. A pod is a wrapper around one or more containers. The confusion comes because 90 to 95% of pod contain exactly one container. Container equal to the application process. Pod equal to the environment in which containers run. Kubernetes also allows pod. Where did the volumes go? This is where Docker Compose and Kubernetes are different. Docker Compose and Compose, the volume belongs to the service container. Backend volume, yeah, service container. The volume is mounted into that container. Kubernetes in Kubernetes, the volume belongs to the pod. So pod equal to a Docker Compose, no? Volume container A data. Both containers can mount the same pod volume. That's why Kubernetes documentation says a pod includes shared storage. Think of pod as a small. Okay, so in the Docker Compose, it can't be shared. Is it so? But in the Docker Compose, different services or images can share the same volumes. If I am not wrong here. You're absolutely right. Docker Compose also allows multiple containers to share the same volume. That's why this distinction is subtle. Uh, both containers mount the same named volume. So the difference is not that Docker containers can't share volume. The real difference is who owns and manages the lifecycle. Okay, who owns and manages? That's where the difference between Docker containers and pods, Kubernetes pods. Mm, okay, Docker Compose app container, backup container. भाई ये बॉट नहीं है भाई इट इज़ अ सेल्फ लर्निंग डिवाइस मैंने इतने अच्छे तरीके से बनाया इसको ये यूज़र के मेमोरी स्टोर करके उसके बेसिस पे अलग अलग रिप्लाईज दे सकता है इट सेव्स द कंटेक्स्ट एंड इट क्रिएट्स अ कॉन्फिडेंस लेवल फॉर ईच यूज़र and I don't have to update it all the time. It updates on the different types of charts that the people in the chat are doing. मेरे को तो अच्छा लगा रिप्लाई. ओके एंड कुबन यहाँ पे वॉल्यूम ऐप कंटेनर एंड बैकअप कंटेनर. द वॉल्यूम एग्जिस्ट इंडिपेंडेंटली. कंटेनर्स कैन कम एंड गो. ओके या कंटेनर्स कैन कम एंड गो. Okay, let me clarify this with the help of diagram. Okay, so for example ये अपना कंटेनर है और कुबरनेटिस को बनाते हैं इससे, एंड दिस इज फॉर कुबरनेटिस. ठीक है. अनिमेश अपने को निकलना है इसलिए मैंने जल्दी स्टार्ट किया. टाइम बताना मेरे को कितने बजे जाना है, फिर चलते हैं. So you know in Docker file how it is mentioned in Docker file. So if you know there is a Docker compose file. Docker compose YAML. In this file we write different services. Okay, in this services we have one for DB. Okay, DB service, so uska image will be here. Image image, and then we have to give the volumes as well. We need to call volumes, and similarly for example there is redis. इसका एक image होगा, there will be an image for this, and then there will be volumes for this. And at the end for example there is one more service, two more services. One will be for backend. Okay, DB backend. And similarly this for this we have our own Docker file, so we will refer to that Docker file. And same front end, it will have its own Docker file that we will refer. And then at the end of this we will mention the list of all volumes present. So one is like DB and another one is Redis, so these two volumes will be there. So that's how it is working. So this is image one. Okay, this is image one, or I'll rather say this is container, because this is image and this is container one. So container one. Similarly this is container 2. Container 2, this is container 3 for backend, and this is container 4. And this all is residing inside a container. Okay, which has its own file systems, and it has its own file system. So this is file system, and these volumes always have an interchangeable copy of these files, so that all the containers can refer to these volumes, to this data, so these containers can come and go. So this is how the containers architecture work. So I feel it's kind of a similar, that's why I was having these doubts. Okay. 10:15 तक निकलते हैं. अभी नहाना भी है मेरे को. अबे 10:15 तक नहीं निकलेंगे, 10:15 तक उसके घर पहुंचना है अपने को. 9:30 बजे निकलते हैं. मेरे को विशाल बोला 9:30 बजे निकलते हैं. तो रेडी हो जा, तू 9:30 बजे निकलेंगे फिर हम. ऑडिबल राइट? ये सुना क्या तूने? So now Kubernetes, let's clarify on this thing. The volume exists independently. Containers can come and go. Yeah, this is what how it works. Uh, and as long as the named volume exists, the new containers can mount on. Okay, these are named volumes to be precise. If I have to be precise. Okay, ठीक है, चलेगा. 9:45 it is then. Then in the pods, volume is separate. Container A and container B. Here the volume is defined as a part of the pod specification. Okay, pod is should also have a YML file. Then in that case, pod also should have a YML file. Mm, edit. Yeah, pod has a YML file. I'm correct. Then every container in the pod can mount it. If the pod is recreated, what happens to the data depends on the type of volume. So empty directory deleted with the pod. Persistent volume claim data survives because it's backed by persistent storage. So I'm guessing most of the time this is what we actually wanted, because we want to persist the data. We don't care about how many pods, how many containers are being created inside the pod, or how many pod are okay. If the pods also can share a data, so it is one level up. uh Sanket, hello, bro. How are you? What is your experience as a Java developer, and how is your salary growth? I'm not a Java developer right now. I'm a क्या बोलते हैं, I'm a front end developer as well as back end developer. So my current role is intermediate software developer. I work on .NET backend and Angular front end. I'm trying to get into Java now because I got bored with my current tech stack. So professionally, I don't have any job experience in Java. Here's the volume is defined as a part of pod specification. Every container in that pod can mount it. If the pod is recreated, okay, so let me see this. Pod kind API version metadata. This is the name of pod. Generate name. This is generated name. Namespace is default. This is the namespace. UID has been created. Generation owner references. Manage field. Then manager kubelet update. Specs volumes. Yeah, this is volume. Name is this. Projected sources. There seems to be many things that we have to know. Containers, AG and host. Image is this. Can we see this image? What this image is on the Docker Hub? Docker Hub. You have what you have? Bro, I have Infosys virtual round in few days. Can you give me suggestions about the company? कंपनी के बारे में क्या सजेशंस चाहिए तुम? इन्फोसिस इज गुड फॉर स्टार्टिंग कंपनी. इफ आई नो योर स्टोरी, if you don't have any other offers in hand, you can go for Infosys and at least grab an offer, and after that maybe you can apply for other jobs as well. So go for it. It's not that bad as people say. As a fresher, you have to start with somewhere, no? Start from somewhere. So it doesn't matter your first company. You have to get the job. Your role matters. So I'm hoping you are getting some good role in there, software developer kind of role. Okay, let's see next things now. ये डाउट क्लियर हो गया अपना ऑलमोस्ट. Bro, I have Infosys virtual round in few days. Can you give me suggestions about company? About company क्या interview के बारे में if you wanna know something then you can ask. Uh, Here the volume is defined as a part of pod specification. Every container in that pod can mount it. If the pod is that I understood, the bigger conceptual difference of pod is mainly about volume. Pod means these containers are so tightly coupled that they should always be scheduled together. They share IP address, network namespace, storage if configured, lifecycle, start and stop together. Docker Compose doesn't have this concept of smallest deployable unit. Docker Compose doesn't have this concept of smallest deployable unit. It simply starts independent containers and connects them via network and optional shared volumes. Okay. For your application, the URL shortener probably doesn't need multi-container. Yeah, ChatGPT bot. That's why I mean Kubernetes usually say one pod one container. It's not technically true, but it's true for huge percentage of real applications. So your observation correct. Docker Compose can absolutely share volumes between containers. The defining feature of a pod, not shared volumes, is that the groups one or more containers into a single execution and scheduling. Um, so does the Docker Compose. mm, is a group of multiple containers. The difference that Docker Compose groups containers logically while Kubernetes groups container physically into pods. Let's compare them. Docker Compose YAML, this Docker Compose up, yes. Docker starts for independent containers, true. Then they can communicate over Docker network, shared volumes if you configure them, restart independently. But Docker doesn't consider that single deployable unit. Kubernetes pod, one deployment contains multiple pods. So pod 1 front end, pod 2 back end, pod 3 MySQL. For MySQL and Redis also we need different pods. Each pod is like the Kubernetes schedules. So pods the equivalent. Okay. So one deployment contains multiple pods. So first there is deployment, and deployment contains multiple pod. Okay, it's saying one for backend, front end, MySQL, my handwriting. One for backend, one for front end, one for MySQL, and one for Redis. So these four pods we are gonna need, it seems. Let's back to the Vishal 9:30 and 9:45. Animesh is saying 9:45, so assume 9:30. I'll finish here by 9:45. We will reach there. Vishal, the AI chat host that I was telling you is now on. It's trying to get the information. Okay, yeah, okay. This is the desktop that I was talking to you, dashboard. It doesn't yet identify you, may I'll add. But see, Vishal, this is the Kubernetes dashboard that I got. It is running on local IP, but it's running through Minikube. If I can go and run here, you can see this is how it's running. Minikube dashboard. It is a Kubernetes environment, local environment. Okay, so you were saying there is a deployment, correct? I have created one fake deployment and example deployment. So for my application, I have to create some new deployment. For that, do I have to write the pipeline, uh, create form? Achha, there are multiple ways to do that. So app name, container image, number of pods, uh, service, internal, external, namespace, default. Okay, this is how I'll create one deployment. This is clear. When you created a deployment in model 2, Kubernetes created a pod to host your application instance. A pod is a Kubernetes abstraction that represents a group of one or more application containers, such as Docker, and some shared resources for those containers. Those resources include shared storage as volume, networking as a unique cluster IP, information about how to run each container, such as that container image, version, or specific ports to use. Either you can apply the JSON here or better from pipeline. Okay. Okay. A pod models an application specific logical host and can contain different application containers which are relatively tightly coupled. For example, a pod might include both container with your Node.js app as well as different container that feeds the data to be published by the Node.js web server. The containers in a pod share an IP address port. So Vishal, can you tell me one thing? I have backend, a MySQL database, and Redis. So for all these three things, should I do I need one pod or do I need three separate pods? One for each, one for backend Java application, one for MySQL, one for Redis. So pods overview: pod 1, pod 2, pod 3, pod 4. So these are these IP addresses, volume. So there will be multiple volumes as well, and containerized app. Containers should only be scheduled together in a single pod if they are tightly coupled and need to share resources such as disk. So maybe all these three will be in a single pod. A pod always runs a node. A node is a worker machine in Kubernetes and may be either a virtual or physical machine, depending on the cluster. Each node is managed by the controlled plane. A node can have multiple pods. Okay, and the Kubernetes control plane automatically handles scheduling the pods across the nodes in the cluster. The control plane's automatic scheduling takes into account the available resources on each node. Uh, Not necessary, but it's good to have separate pods as real world production scenario. You can add different resources to all the pods and handle scaling accordingly. Okay. Separate deployments makes sense when components need different CPU memory limits of scaling rules. Just avoid splitting things only for production vibes. विशाल स्ट्रीमला लाईक करशील यार. I started the stream very early today. I usually start at 10, so the usual audience will not join that, I know. Okay, there is node, there is pods inside the node, and pod contains volume, containerized app, node processes, troubleshooting with kubectl. In Model 2, you used kubectl command line interface. You will continue to use in Model 3. Get, describe, logs, execute. Mm, okay, so I can go and create a new workspace. Can't I create a new workspace? No, I can't. You can use this command to see when the application were deployed, what their current statuses are, where they are running, and what their configurations are. Now that we know more about cluster deployments, cluster components, and command line, let's explore the application. Check application configuration. Let's verify that application we deployed in the previous scenario is running. We'll use the kubectl get command and look for the existing pod. So this is running. There is no issue in that. There is only one pod running, which is a demo pod. If no pods are running, please wait for a couple of seconds. List the pod again. You can continue once you see one pod running. Next, to view what containers are inside that pod and what images are used to build those containers, we run kubectl describe pods. So okay, kubectl describe. Kubernetes has one good thing that these commands are same, whichever the platform or whichever the service that you are using. For example, AKS, be it AKS, EKS, or whatever the hell it is, like this minikube local instance. So all these commands will be same everywhere. So what is giving kubectl describe pods, name, default, all this information we saw. Like it's the YML file. Uh, it's the deployment YML file if I'm not wrong. Let me check deployment YML file. Edit resource version. It's a pod file, not this. So this is this. If I go and edit this, yeah, default is there is no IP mentioned over here, so we will get it only when it's running, not in the actual YML file. So what was the command? Kubectl describe pods. And also, if you have a backend, frontend, and Redis in different pods, and let's say your Redis pod goes down, then you still have backend pod fallback to serve the request. But if all of them are in one pod, then entire application goes down if Redis is the required container, as Kubernetes generally treats the pod as unhealthy and restarts the entire pod. Okay. Just ignore these in between messages. Let me stop this. During the restart, the front end and back end also become unavailable. Okay. Okay, I understood. And this automatically generates pods. If any of the pod is unhealthy, you mean to say, in that situation when the pod is unhealthy, it regenerates a new pod. Okay. For this practice, I can have complete backend in one pod and complete front end in another pod. I understood the concern. We see here details about the pods, container IP, address, ports, everything, life cycle. They'll become familiar by the end of this tutorial. The describe subcommand can be used to get detailed information about most of the Kubernetes primitives, including nodes, pods, and deployments. The describe output is designed to be human readable, not to be scripted against. Show the app in the terminal. Recall the pods are running in an isolated private network, so we need to proxy access to them so we can debug and interact with them. To do this, we will use kubectl proxy command. I have used this. So moving ahead, फिर से आ गया क्या information हमने तो किया था ना. Executing commands on the container. We don't need to specify container name because we only have one container. Executing commands on the container. We can execute commands directly on the container once the pod is up and running. For this, we use the execute command subcommand and use the proxy name as of the pod parameter. Okay, not regenerate the pod exactly, but cube restarts the same pod. Okay, and if there are back-to-back restarts, then it goes into crash loop back off stage and service becomes completely unavailable. So it restarts the pod, not regenerate. Now let's start a fresh session in the pods container. Let me execute this. Okay, there is only one pod, so it took that pod. Again, it's worth mentioning that the name of the container itself can be omitted since we have only single pod. And now let's start the bash session in the pod container. Okay, like it is the exact same command like it used to be for Docker container. Instead of kubectl execute, it was like Docker execute in the integration terminal. That was -it. It is -ti. Container ID, now it's pod name, and --bash, it was bin/bash or sh. Pod will generate only when scaling is configured, for example VPA, and your primary pod is full utilization. Okay, once the first pod is utilized completely, then only new this starts regenerate. Understood. So now we are inside the pod. So does the docker commands work here? Let me check. Docker ps. Docker command does not work over here. So ls. Acha, there are these things. Bin, Asian host. These are some kind of, I don't know what are these exactly. Where are the files? What does this library has? cd lib ls. It has uh, apk. What all these files? We are not aware of. cd. Okay, let's see. Read further. We have now an open console on the container where we run our Node.js application. The source code of the app in the server.js is cat server.js. Okay, there is only one file it seems. So let's see server.js file is there or not. Can't open server.js, no such file directory. There's no such file or directory. Mm, why we don't have server.js file? We missed something in between? No, I don't think so. We missed anything. Here we use localhost because we executed command inside the Node.js pod. If you cannot connect to localhost 8080, check to make sure you have to run kubectl execute command and are launching the command from within the pod. Kubectl execute command. Kubectl is not present inside the pod. To close your container, type exit OK. Using service to expose your app. Mm, it would have been good if we directly deploy our application, but I'm not sure. We have this pod. Uh, is pod YML directly equal to the image? Somehow we have to get our image inside this pod. Then only it will start. That's what I'm assuming now. Mm, let me add this now. Using a service to expose your app. Okay, this is what we need, I guess. Learn about a service in Kubernetes, understand how labels and selectors relate to service, expose an app outside a Kubernetes cluster before you begin the shell commands in this tutorial. Okay, okay. Service and labels. Mm, let's verify that our application is running. We will use that kubectl get command and see kubectl get pods, get services, and then expose. So we'll do this. Now we have to exit first. Clear. Then run this. This is running, and then kubectl get services. So there are two services running. To expose this, we did this already, didn't we? Error from server not found. Deployments app Kubernetes boot camp not found. Kubernetes boot camp नहीं है ये, Kubernetes है ये. Deployment / Kubernetes. Mm, let me write hello node. No. अच्छा, these are services. अच्छा अच्छा अच्छा. So this service already exists. What is this address then? This address. It used Kubernetes bootcamp. We don't have as such. Bootcamp not found. We have now running service called Kubernetes bootcamp. Here we see that service received a unique IP. We don't have this service created. We missed something in the documentation. Kubernetes pods are model. Pods have life cycle when a worker node dies. The pods running in on that node are also lost. A replica set might then dynamically drive the cluster back to the desired state via the creation of new pods to keep your application running. As another example, consider an image processing backend three replicas backed. A Kubernetes service is an abstraction layer which defines a logical set of pods and enables external traffic exposure, load balancing, and service discovery for those pods. So let's see in this. We have services. We have Kubernetes service. We don't have Kubernetes bootcamp service running. We have these two services running, but not this. So expose, if I say Kubernetes directly, Kubernetes, the server doesn't have resource type Kubernetes, so it's under default. Actually, there is a resource first. So what is the resource? Mm, Vishal was saying something about Ingress. ये क्या है फिर? Classes, services, type load balancer, cluster IP. A service in Kubernetes is an abstraction which defines a logical set of pods and a policy by which to access them. Services enable a loose coupling between dependent pods. A service is defined using YAML or JSON, like all Kubernetes and objects. Um, the set of pods targeted by a service is usually determined by label selector. See below for why you might want a service without including a selector in spec. Although each pod has unique IP address, cluster IP, node port, load balancer, we don't have node application as in such in that one. So maybe that's where the issue is. So let's fuck this and simply start our own application. Uh, so for this, I have to give some data to ChatGPT so that we can start on our application now. We have all the setup as right now. We have all the images. We have everything. So I'll give a good prompt. Wait. We have to speed up the process. डॉक्यूमेंटेशन यहाँ तक सही था उसके आगे हम कंफ्यूज हो रहे हैं अभी नॉट एग्जैक्टली कंफ्यूज बट इट्स टेकिंग आउट ऑफ okay, so let's give the prompt. Okay, I have now complete setup. I created this dummy deployments pod and service. Now I'm ready to deploy my application. So tell me in short first, how should I do it? सर्दी क्यों हो गई भाई अचानक से? You are ready since you already understood the Kubernetes basics, deployment, replica set, pod services. The next step is to replace the dummy image with your own application. Phase 1 backend only, today Docker image, deployment, pod, and service. Yeah, this is what we have to do. Build your Docker image. We have Docker image. Make the Docker image available in Minikube. Okay, I don't know how to make that available in Minikube, but we'll see. Create backend deployment YAML and then create backend service YAML. Verify you can access the backend. Don't involve MySQL or Redis yet. Deploy Redis. So let's start with the phase one. So let's start with phase वन. मैंने शॉर्ट में बोला है, इसने इतना बड़ा ऐसे लिख के दिया मेरे को. इतना कौन पढ़ता है इंसान. uh let's deploy our Spring Boot application to the pod now. Step 1, build your backend image. First tell me how you currently build your backend image. Current URL shortener backend. No, I use Docker Compose up build build backend. How we do that actually? Do we have anti-gravity open? Let me open the ID where my application resides. Open descent URL shortener. So this is what we have, and how we used to build it. What was the command? So Docker PS. So there is Minikube. Docker compose up -d build. So this is what the command we were using, I guess. Uh, Docker compose. What was the command? Docker compose up hyphen. This is the command that I was using. This. So I was using this compose. Okay. Backend is fine. This command or something else. Make the image available in the Minikube. Your Docker image currently exists here. Your Mac Docker engine URL shortener backend. Your pod will run here. Minikube and this. The Kubernetes node must be able to pull the image. Where is my live chat event? My live chat is here. At least इतना step में करके जाओ. The Kubernetes node must be able to pull your image. There are several ways to do this, but for Minikube, we will use the simplest one after we confirm you are building the image. Create deployment. We will create gate Kubernetes backend deployment YAML. Give me first command to run. Confused us actually. Yeah, Docker file is there. Don't worry about that. Check the images exist. Yes, these images do exist, bro. URL shortener, backend, frontend, everything exists. Don't run Kubernetes says once you confirm Docker images, I'll give you the next command. Okay, let me give it the response of Docker images. Mhm, mhm. Okay, guys, don't forget to like the stream. Perfect image is already built. Next command is to load the images into Minikube. So Minikube image load balancer. Yeah. Uh, okay, we will run this command over here. यही image का नाम है ना अपने. This is Docker 1 URL shortener. Uh, it's Backend 1. Minikube SSH. Linux. The program include. We don't have anything yet here. Great. You are now inside the Minikube node. Critical images. If try Docker images. Warning, this output is okay. We have the Docker image now for our backend application. Now simply we have to run this and we are done, it seems. Now our image is inside the Minikube now. Next step is to create first deployment in YAML inside. Create a folder in your projects. So in our projects, where are the projects now? Do I need to create a project? Yes, but not the new project. Keep your Kubernetes file inside your existing URL shortener. A typical structure looks like this. Mkdir key k8s. Okay. Make directory. There is new directory. Then touch. Touch is very funny comment. So touch is not available. Touch is not available in this one. Acha, touch is just to create a file. Did it create two files? It should not. Okay. One thing I'd like to know, can you show me your project structure? Run the command. This so cd -open out and do this. Tree command is not available. Nice. If you don't have tree installed, find max path. Okay. This is the structure. Let me give this structure to this. You are currently inside the Minikube VM, not inside your project. on Mac, which is not where your project lives. Exit minikube first. Exit and then run this command. Mm, what was the command? Not this here. I don't have to run this here probably. Clear and verify you are there. Then create. Acha, inside my project I had to create this. Oh, okay. I made a mistake. And then uh, check your folder structure. So yeah, this is my folder structure. Take it, shove it in your ass. This. Hello, boss. Hello, Atharva. How are you, bro? I'm about to end the stream. How was your day? क्या क्या किया तुमने कल रात तक तुम बैठे हुए थे जावास्क्रिप्ट खत्म कर रहे थे हैव यू फिनिश्ड द कंप्लीट जावास्क्रिप्ट लिटरली लाइक step 1 write your first deployment open uh inside this I have to create a file. So where is k8s folder? So this is a k8s folder and here I have to create a file. This. Okay, so now we have to write the file. It has given us this file. Let's write this, copy this file as it is. Okay, before we apply, let's understand every field. API version is this, which API should interpret this YAML file. Deployment service v1 config map job patch v1. Okay, kind of a deployment. This tells Kubernetes what you want to create. Leak minister finally resigns. Yes, it just started. The government should tremble. They are doing so many wrong deeds right now. Everybody is frustrated. No, JavaScript have details. Just stream end करके आया. Nice. DSA के साथ JavaScript आज DSA के साथ JavaScript आज ओके. JavaScript यूज करके क्वेश्चन सॉल्व किए DSA में. JavaScript बहुत आसानी से क्या बोलते हैं. JavaScript is very good language to solve DSA. You don't have to write so much of a code like Java or any other language. JavaScript is nice. It has so many useful functions that you can use. Okay, where were we? Okay, this is enough for me. What's next now? We have template spec, metadata, and deployment. Apply the deployment from the root of your project. Run this. If successful, you'll see something like this. Okay, deployment dot apps slash backend created. Deployment. Where did it create? I'm not sure exactly. Mind clash हुआ. मजा आया. Two languages clashing with each other. Nice. मजा ही आना चाहिए. That is where is most important part. Okay. Check if deployment exists. Yes. Backend and hello node. Backend has 0 pods available right now because we haven't started it yet. Now check if the deployment exists. Yes, we did. Available 1, available 0, available 0. आई हैव केम मोर अर्ली. एक बंदे का मैटर हो गया, वो ब्रेकअप बंदा जिसका मूव ऑन करवाया था. बड़ा मैटर. भाई तुम कितने लोगों की ब्रेकअप सॉल्व करवा रहे हो भाई? बढ़िया है. गाइज यू कैन कनेक्ट विद द मॉडरेटर इफ यू हैव a new fresh breakup. This is actually good sign the deployment exists, but 0 1 ready means Kubernetes created the deployment, but the pod is not healthy yet. Now we debug the Kubernetes. Engineers, okay, get the pod name. So this is an overhead. Let me get, yeah, okay, so clear. kubectl get pods. So we have these 2 pods. Error, there is some error in this one. The pod is unhealthy. That is the correct nomenclature. The pod is unhealthy. Describe the pod. kubectl describe the pod. kubectl describe pod. So pod name is this. So let me paste the pod name. Paste, and let's see. Mm. ओ ओ ओ ओ ओ ओ क्या हुआ, क्या हुई? कौन मैसेज कर रहा है इतना? ये क्या था? हाय शॉर्ट्स, हेलो, हाय ब्रो. Is somebody spamming something? हाय बोल रहा था बार बार. हेलो हेलो ब्रदर. क्यों स्पैम कर रहे हो मैसेज? थैंक्स अथर्व, डिलीटेड दैट. आई हैव केम मोर. वो, हाँ वो मैंने पता चला. इसको बंदी ने अपना मैटर सीन एंड कर दिया. बंदा स्ट्रीम के बीच में आया था बताने. अच्छा, नॉट बिकॉज ऑफ हिम, अलग मैटर हुआ. ओके ओके. 1 मिनट का टाइम आउट है बस. ओके. यू डिलीटेड दीज मैसेजेस अथर्व? Okay, fine. Guys, don't forget to like the stream. भाई ऐसे गलत चीजें मत बोलो अथर्व. There is some, our pod is unhealthy, so that is what the scene is. I don't have much of a time left. So let me give this to ChatGPT now and tell me what's the issue. Guys, meanwhile, please do like the stream. 1 करोड़ का प्लेसमेंट कैसे होगा? मेरे को लगा तुम्हारा प्लेसमेंट होगा. 1 करोड़ का प्लेसमेंट हमारा भी नहीं है. 1 करोड़ का तो हम क्या बताएं भाई. 1 करोड़ के प्लेसमेंट के लिए यू नीड टू हैव सो मेनी थिंग्स राइट ऑन योर रिज्यूमे. बहुत सारी चीज़ें करनी पड़ेगी भाई. आई कैन सी दिस नाउ ऑन द वीडियो. अगेन उसको मूव ऑन करवा दिया. बढ़िया यार, हमारी भी लाइफ की कुछ प्रॉब्लम सॉल्व करवा दो अथर्व. 1 करोड़ का पैकेज दिए. लीड कोड के सारे 3,000 क्वेश्चंस कर लो. डीएसए के सारे अवेलेबल प्रॉब्लम्स कर लो भाई. और 10-12 प्रोजेक्ट बना लो. Add it to your resume and then start applying. Excellent. This is exactly how Kubernetes debugging where your Spring Boot application crash. Notice these lines: pulled image found, created container, created, then exit code. Okay. Our image is failing. Now let's inspect the application itself. Uh, If the logs are very long, you can also use till 100. Let's do this. Connection refused. Okay, connection refused as in uh, the Redis connection must have been refused. So let me start the Redis now. Redis is running. Backend 1. It did not start. Connection refused with whom? Okay, this is how we have to test this. So let me write this in the Notion logs. So Spring started. Uh, Config registry error creating bin with name. Fly way initializer in the class path resource. Yeah, because we have the integrations, the migrations files. I understood. Uh, 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 src main, not repository, not DTO, not controller, not response, not service. Mm, where are the migrations present? Flyway. Okay, Flyway is not been this. Flyway हमने किसके लिए we have installed Flyway for migrations, some doing some migrations. I am data. एक सेकंड, क्या हो गया? मैं पहले का मैसेज अगेन उसको मूव ऑन करवा दिया सॉर्ट. ऐसे ना करे भाईजान. गुरुजी, गुरुजी को कौन सिखा सकता है? आई एम डेटा इंजीनियर इन अ कंपनी. डेटा ब्रिक पर काम करता रहता है. ओके, बढ़िया है. फिर डेटा इंजीनियरिंग में भी यू कैन गो अहेड. डेटा इंजीनियरिंग इज अ वेरी गुड फील्ड. इट पेज वेरी गुड. If you stick around, it pays really well. So it is some migration issue, the packet. Let me give it to daddy. Flyway migration. So perfect. This is actually Kubernetes first. Kubernetes we are solving. Let's think engineers instead just fixing unable to obtain connection from database. Notice what it doesn't say. It doesn't say MySQL username is wrong, password is wrong, table is missing. Flyway migration failed. Can't even reach the database. MySQL container. Docker Compose automatically created this as a host name, but today your Kubernetes cluster looks backend pod. So verify this, you will probably see hello node. This is huge Kubernetes lesson. Unlike Docker Compose, Kubernetes doesn't magically create the whole. Okay, we don't even have the MySQL dataset inside the Kubernetes pod. So that is where the problem is, and hence it is refused, connection refused. So our pods doesn't have all these things. Kubernetes describe pod, get pods. We have only one pod running, so we need to write another pod for backend and use that pod for this backend application. Okay. So guys, don't forget to like the stream. Yeah, I'm gonna take off early leave today because we have some function at friend's house, so we have to leave now. My friends are waiting outside, but I'll continue. I understood the problem. This is how we can log the error because our this pod is not healthy and hence it did not start. And if I go to the Kubernetes cluster, कहाँ गया Kubernetes cluster? This, and there are pods. Okay, let me go to the pod and see there is this pod and it is not running. There is an error. So if we go back of restarting failed container pod because error, there is an error. So we have to see the error. The error is this. This is how we are seeing the error. कहाँ गया? So this. So I'll create a Java, sorry, MySQL container and MySQL ka pod separately, and I'll connect those pods, and that we will do tomorrow. I have to take a leave early. जिसने भी like नहीं किया है, please do like the stream, and we will continue on this part tomorrow. And tomorrow also I'll start early, like at 8 or 9 I'll start. Okay, so be there, and to get notified, you have to subscribe to the channel and turn on the bell icon so that you will get the notification of the stream whenever I'll be online. ये जावास्क्रिप्ट में बार बार कोड सिंटेक्स देखना सही है? हाँ, शुरुआत में देखना पड़ेगा, काफ़ी सारे स्टाइल है। यस यस यस, या जावास्क्रिप्ट में एक ही चीज़ करने के मल्टीपल तरीके हैं भाई। वो एक एडवांटेज भी है और ड्रॉबैक भी है जावास्क्रिप्ट का। यू कैन राइट फंक्शन लाइक इन 3 or 4 different ways. You can create variables in different ways, too many things. So it's up to you. Try to follow one approach, and rest it's up to you. So चलो guys, I'm sorry for this. अभी just मजा आना चालू हो गया था, but nevertheless we will come online next today. Sorry, tomorrow again, and then we'll resume, because दोस्तों से भी मिलना ज़रूरी है, दोस्त आने वाले हैं, कॉलेज के भी दोस्त आने वाले हैं, so all these things are there. So we'll do that. जिसने भी like नहीं किया, please do like the stream, and we'll solve this error tomorrow. I know what's the error is. We need pod for MySQL database, and once that is created, we have to connect this and it will be done. Okay. काफ़ी सारे स्टाइल है एकदम। यस यस यस, मैं जावास्क्रिप्ट को हेट करता हूँ थोड़ा बहुत, इसलिए इवन दो आई एम अ जावास्क्रिप्ट डेवलपर, बट स्टिल आई फील दैट प्रेशर ऑफ नॉट हैविंग कंसिस्टेंट syntaxes everywhere. So guys, please do like the stream यार। कल बहुत मज़ा आया, कल तो we got almost 25 likes, so it was very nice stream, and we will continue on that high note. Correct? पढ़ लेंगे थोड़ा थोड़ा, हाँ पढ़ लो। यस, डीप नहीं जाएंगे अभी, डीप मत जाओ जावास्क्रिप्ट में ना। जावास्क्रिप्ट में बेसिक्स अंडरस्टैंड कर लो। डू यू नो हाउ होस्टिंग वर्क्स in JavaScript? If you know that, that means I can say you are at a very good level in JavaScript. Okay, बारिश भी स्टार्ट हो गई यार। हाउस माय न्यूज़ पे यार, मेरे को तो मस्त लग रहा है। नाइस, चलो, थैंक यू ऑल फॉर ज्वाइनिंग द स्ट्रीम। जिसने भी लाइक नहीं किया, प्लीज डू लाइक द स्ट्रीम। एटलीस्ट we should get 10 likes. I'm ending the stream early today because I have to go to at my friend's house for the function. So hey, किसने dislike किया फिर से? Guys, yeah, don't do this masti. Okay, chalo, thank you all for joining the stream. We will continue on this left out error. We will come back and do this tomorrow. Meanwhile, don't forget to like the stream, don't forget to subscribe to the channel and turn on the bell icon so that whenever I come online tomorrow at 8 p.m, you will get a notification, and from there we can start on this. I'm planning some videos as well, so you will get to see different videos on tech stacks and the projects that I've done in the past and right now what I'm doing. So stay tuned for all those things. Meanwhile, take care. Good